Hello everyone. My name is Simon Millet. I'm a scientific engineer at Novartis. You will, for this training, we will see the tundra wildfire in Siberia in 2020. So you will also have a closer look of WEkEO's products, their structures, format, variable, and how to explore and plot them. So first, we will explore the netcdf file. Then we will make a basic plot of carbon monoxide. Then we will visualize carbon monoxide at a single point. Then we will compare the result with concentration of nitrogen dioxide. And finally, we will use the Sentinel-3 data to see two images before and after wildfire. So this training focus on tundra wildfire in 2020 in Siberia. So during the summer, Siberia expressed massive wildfire, mainly due to extreme climate condition with high temperature exceeding 48 degrees and prolonged drought. And the wildfire is not a typical forest fire because it affects the tundra fragile ecosystem that is usually not highly flammable. And so during this training, we will allow to see the evolution of wildfire during the summer 2020 with the mass concentration of carbon monoxide and nitrogen dioxide. And finally, we will use an observation product to image of Sentinel-3. Sentinel-3. So first, the Jupyter book must be set up with all necessary libraries. So for this training, we will use 8 libraries. So there is ggplot2, it is for creating graphic. Dplar, it is for manipulating data. rcolorBrowers, it is for color palette. netcdf4, it is for manipulating netcdf file format. GridExa, it is for arranging multiplot in a single page. Hybridate, it is for date time data. And raster is a package for reading and manipulating special data, especially for using for Sentinel-3. So first we load all the libraries. If you do not use if you use another support, you can copy this line to download all the libraries. So for this training, we will use WEkEO's data. So the data are already downloaded in the folder data here. And it was downloaded in the WEkEO's viewer. You have a link here. You can explore all the products. So for this training, we will use two different datasets. First, it is the CAMS global reanalysis in Siberia area. The elevation, it is at 1000 hectopascal. That is close to the ground. And the variable, it is carbon monoxide and nitrogen dioxide. And it was a daily means between these two dates. And the second data, it is a Sentinel-3 image for two dates in the 8th of June and in 27th of June. So for this training, you don't have to download it because the file are already downloading. But if you want, it is possible. You have whole information about the dataset. you will need to have your own WEkEO credential, username and password. And if you have not, it is possible to creating in this link here. So first we set the path of the netcd file. We load the netcd file, and you can see here all information about the netcd file. So there is one variable that is carbon monoxide here. And here you can see the dimension, so the time, the pressure level, it is only one, the latitude and longitude. And here it is the global attribute to have more information about the dataset. So first we load all the variable. You can have information about, for example, carbon monoxide variable. So the dimension of variable, and so it is longitude, latitude, and time. And here the value for longitude, latitude, and one time. It is possible to do the same for time, but you can see here it is a number, not a date. So in R, we should convert the number to a date with this function as POSIX. You put the time variable and the origin. The origin is noted in the information of time variable. It is units here. It is since January 1970. Okay, so we run the sale, and you can see now it is a date, not a number. So now we make a basic plot of carbon monoxide. First, we determine the figure size. Then we create a data frame for the index of time. So we should choose here the index time equal to 7, but you can choose over index time. And it is possible to visualize the data frame that is depend of longitude, latitude, and you have carbon monoxide. So now we make the plot. So we use ggplot function. Then we put geom tile where we put all the data, so the data frame with the column of longitude, column name of longitude, latitude, and carbon monoxide. Then we select the color scale option. After it is aesthetic option, so general aesthetic option here, title and subtitle. Here it is for legend and the size of legend. And then we save the figure in the folder figure here, and then we plot the figures. So here we can see the mass of carbon monoxide for this date. We can see a very high concentration here of carbon monoxide. It is around longitude 150 and between latitude 65 to 70. So it is due to wildfire. So now we will see the carbon monoxide at a single point. Because in the previous figures we saw a high concentration of carbon monoxide, especially at this point. So first, about the dataset, we create a data frame that depend only on the time. So we find here the index of the nearest coordinate of this coordinate. And the nearest coordinate, it is this one. So we have the index here. We do the same for the time. between June to the end of October. And now we create a new data frame with the carbon monoxide dependent only on the time because we choose one index of longitude and one index of latitude. So we can see here the date and the concentration of carbon monoxide. Then we plot the time series here. So we use a geom line. And here it is a general aesthetic option. And we can see the mass concentration of carbon monoxide between from June to the end of October. And the figures show the high concentration of carbon monoxide, especially from mid-June to the beginning of July, and a high concentration at the end of July, likely due to wildfire. So now we make a comparison with nitrogen dioxide. So nitrogen dioxide is an atmospheric pollutant that serves as an indicator of pollution from road traffic, industrial activity, and biomass combustion. Because of there is no significant human activity in the study area, the observed nitrogen dioxide level are likely due to biomass burning. So for this part, first we load the netcd file. It's the same code that we have seen before. We find the index of the nearest coordinate. It is the same coordinate than before. We find the index of time, and we create a new data frame of nitrogen dioxide. You can see here. So the data frame depends only on the time. And finally, we merge the two data frames. So for this, we create a new data frame. We put the data frame of carbon monoxide and we joint by date the nitrogen dioxide data frame. Up. And here you can see the date and the concentration of carbon monoxide and nitrogen dioxide. So now we can plot the time series. So we use geoplot and we put two lines of geom function, one for nitrogen dioxide, the second for carbon monoxide. So here you can see the concentration of carbon monoxide and nitrogen dioxide. So the figure reveals a strong correlation between the two indicators. So together, this indicator can be used to identify wildfire. But we can see here a peak of nitrogen dioxide, but not in carbon monoxide. It is it is due to more efficient combustion in the tundra vegetation, resulting in less carbon monoxide and more nitrogen dioxide. Additionally, the longer atmospheric lifetime of and higher mobility of carbon monoxide might explain its lower local concentration. Okay, so now we will see Sentinel-3 data. So Sentinel-3, it is a satellite. So we will see two date, two image. It is before wildfire and after the wildfire to see the difference between the two images. So it is different to map satellite image. So first we open the netcd file. So there is different bands. S3 it is for red, S5 it is for green, and S6 it is for blue. So we open the three bands. Then we extract the radiance of variable of each netcd file. And then we convert in a raster object, then thanks to the function raster. And we improve the image visualization with stretch to improve the contrast of the image. And then we create the RGB image. So we put all the band in a single variable thanks to the stack function. And now we plot the RGB image. So we put the output file here. We open the PNG graphic and plot the image. And then we display the image. So we can see here the image. So there is white, red, and green in the image. That is for cloud. But that is interesting. It is this area. We can see some patch here, but just one. So now we will look at the same image 20 days later to observe the change. So it is exactly the same code, but for another date. And you can see here the image. So we can see a whole many patch here, 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 that is not seen in this image. So the patch is it is a burn area. So during these 20 days, there is you can see the burn area, and here it is a fire that is always active. So Sentinel-3 satellite allow us to visualize the extent of wildfire. So now the training is finished. If you have a question, do not hesitate.
Thanks a lot, Simon, for the presentation. We have a few questions for you. And I think people were trying to do the tutorials at the same time as you, so we will probably have a few questions later also. The first one being, I think we often have this question, why did you decide to present your R tutorial in a Jupyter Notebook?
Yes, I prefer because it is you can have many text and code in the same page. It is more useful, I think, for presentation. But it is possible to do the code in the in RStudio. There is no problem.
Okay, thanks a lot. This one, a very nice presentation. Can we use this tutorial to study other areas or adapt it for other gases emissions?
Yes, of course. You can use this training, for example, to have an example of creating a map. And you can study, for example, emission of greenhouse gas near the city in Europe or Asia or everywhere you want.
Okay, yeah, as long as there is data, it should be fine.
Yes.
Okay, thanks a lot. Then we have this question. I think I can answer it also. Where is the Jupyter Notebook file located? I couldn't find it on the Jupyter Hub in the public folder. So for the tutorials on WEkEO training, For the tutorials to be available on the Jupyter Hub, it needs to be synchronized with the WEkEO GitHub. So right now, this action hasn't been made by the user support. So you can only find the tutorials on the webpage of the event, but at one point it will be available on the public folder if you want to take a look later. Okay. And yeah, if you have questions about the notebook on the public folder, don't hesitate to contact the user support also, of course. Another question, this time about the tutorial also. How is carbon monoxide data visualized in section 5.2?
Okay, in section 5.2, it is a visualization of carbon monoxide at a second point. So we have the data set with the concentration on carbon monoxide, but dependent of latitude, longitude, and time. And for this section, we select the one longitude, one latitude, and carbon monoxide dependent only on the date. And then we use geometry to put to create a time series of carbon monoxide.
Okay, thanks a lot for the explanation.
Yes.
And yeah, I think there is more detail in the tutorial also, obviously.
Yes.
Okay, thanks a lot. So I think that's it for the question. So thanks again, Simon, for the presentation
Yes.
and the
Welcome.
tutorial.